The topic of the presentation is German-Canadian radar cooperation potential. You may be a bit surprised if you know that there's 3 major, very professional, very competitive radar systems around the globe. One from Italy, one from Canada, one from Germany. And we really are we're very much competing in the market. So why on earth should we want to cooperate? Is it because we give up? Is it because we are a bit crazy? Or our bosses don't have new ideas to confuse the customers? No, I think there is some good reasons for cooperation. And the main reason for cooperation is the customer. I just put an example here from the high north of Canada. If you look into today's customer's need, you may find out very quickly that collaboration of radar systems, especially the Canadian and the German one with different characteristics, makes fully sense. Think about ship detection. Canada has got a radar system that is excellently equipped for large area coverage. Germany has got a high-resolution system that is perfectly for ship identification. Canada has used RadarSat-2 and will use the RCM system for large area ice monitoring. X-band in Germany can contribute to identify special features in ice. And the same holds true for a whole lot of other applications. So we may want to compete. From a customer point of view, this looks a bit silly from time to time, because each of us individually will not deliver the solution that the market wants. And that's a challenge. So we were forced to talk to each other a little bit. If you look at the 2 mission timelines of RadarSat, that's the blue part on the top, and of the German system, TerraSat and Tandem on the lower side, the yellow part, they are quite in parallel. So technically speaking, yes, we could talk to each other. There's a long-term data flow, and that could result in long-term business opportunities that are worthwhile to explore and develop, and where it's also worthwhile to invest money, not just for technology stuff, but also on the business side for developing services. And at the same time, and this is not shown on that slide, the systems are differentiating in a very good direction. Germany is looking very much into very high-resolution systems. Canada is optimizing for revisit and coverage, so they are getting even more complementary than they are today. So that's a good start for discussions. From an industry perspective, we saw 4 major fields where we believe cooperation makes sense. On the one hand, it's developing an operational concept for customers, here using the example of the High North. Why in Canada? We could do concepts with customers around the globe. Well, there's one big thing, as you saw on the slide before. Canadian public and private customers are using, in a very professional way, Earth observation services for more than 20 years. That's great. That's the feedback and stakeholder platform that we need to develop ideas, to get good and valuable feedback. In Germany, we are really the newbies. We didn't launch anything substantial before 2005. So that's great if we can use that Canadian asset and expertise. A second point is the idea to develop joint applications on a more technical level. For example, for infrastructure integrity. If you think about the high north in Canada, there is permafrost. So it's thawing in summer, it's freezing in winter, it's moving continuously the underground. That is putting a lot of stress on existing infrastructure. Think about pipelines that may break, houses that may collapse, bridges that are under strain. Here, RadarSat is used for wide area coverage. TerraSat can identify the spots of strain on an individual infrastructure. Why not come up with a joint service there? On maritime security, I already mentioned the combination of X and C-band for ship detection and identification and ice charting improvement. That's where we want to collaborate. Number 4 is the next generation collaboration. There is a Canadian system RadarSat constellation mission. It is funded, it's decided, and I wish Germany would be as quick with its TerraSat next generation, but for some reasons we're not. Still, we see a big potential for collaboration. RCM's ground segment concept has got a similar philosophy to what has been done in Germany before. Why not consider to use that and port it for TerraSat next generation? And we believe that here a collaboration with MDA would make full sense to the benefit of both companies. Moreover, There is a partner system to Terasa. It's a Spanish system called PATH that is successfully working with the Exact Earth AIS system. That's a system to identify ship signals that are sent from ground, so I know what type of ship is that I see in the image. That will be something of high interest also for the Terasa Next Generation. And Exact Earth is another Canadian company. On the global market approach, that's key. It's not sufficient to use Canada as a test bed. That's interesting. That's the learning ground. But it only makes sense to earn your money back if you go global. So here I believe that there is a potential to work with Canadian value adders, but also with our best competitor in the market, MDA, for a number of dedicated applications. And I'm happy that John Bowers will be on the floor for the panel to consent or to disagree later, or to have a heated discussion with me on that. I will skip that techie slide. I think that's something for the nerds. That's what I wanted to show for ice monitoring. It doesn't show very well in the end. You see that large area coverage on the one side of the picture, and on the other side, the smaller picture. This is Terasa, where you can see the ice ridges in the end. And that's what you want to see if you've got a smaller boat. The ice ridge is piling up, and you need to know where it is. You may get stuck otherwise. Another example is ship identification. So if you look into that high-resolution picture on the top, well, it looks a bit blurred, I agree, and only an expert may say that's a ship. Anyone else would say that's a pretty bad image. But for radar, that's great, and that's what the experts use to say this is the kind of ship on the ground. That's what Terasa provides. The RCM system would be perfect to identify the ships, and we know where to look at. That's the concept of cross-queuing of systems. One gets the broad area coverage, the other one comes later and focuses in. On infrastructure monitoring, this is how infrastructure like roofs and houses looks in a radar image. I admit again, that's something for experts to interpret. At least we can see something, and it's useful, for example, to assess infrastructure integrity. If we do layer stacks of images, we can monitor movements from 2 millimeters per year. So if you look at this example of the Berlin main station that was prepared by our colleagues of DLR at the research center in Oberpfaffenhofen, you can see these little dots. The blue dots mean it's a stable thing. And if they get yellow and if they get green, it means the ground is moving, the bridge is moving. This is what you may want to know to assess your new building stability. Okay, Berlin is not permafrost and the high north, but in the end, to build that station, a lot of landfill had to be done, a lot of tunnels were done, so it's in the end an unstable ground that still needs to settle. So the same example would hold true for other environments. For the Terasa Next Generation, as I said, we will differentiate. Terasa Next Generation will go to a resolution of 25 centimeters on ground. That's new for radar. And that would go into the very high resolution area, whereas the RCM part in Canada would still focus on large area coverage. I think that's a good complementarity for combined services. That's a little example for operational scenarios. All these little stripes mean if you combine RadarSat and Terasa and PATH, you get a better revisit or a better coverage in 24 hours for any part of the world. The example shown here is the waters that Canada believes it needs to control. It's a bit more than the 200-mile zone, I must say. In the end, the question is where to put all these data, and that's another collaboration field. It's not enough to have an image or a map. What's the value of that? You need a data flow in something like a situational awareness center to take action if you need to do, for example, a search and rescue operations. That's another example for a collaboration project that has already been started by our colleagues from Cassidian. It's called the Passages Project, with partners from Canada, like the Dalhousie University, like Exact Earth again, and stakeholders that look into the operational use, combining Earth observation, airborne means, and other tools. The principal question you could ask from a taxpayer's point of view, if I use Earth observation, how can I save fuel and money for the expensive means, like ships and airborne means, to direct them better and quicker to the place where they need to be? And I also mentioned Kaptein for another reason. You know that Astrium is very good in confusing everyone by renaming every 2 years. Now, 2 years are done. We will rename again. Now, Astrium will be Airbus Defence and Space, and Kaptein will be integrated with Astrium Services, where I come from. So we prepare for collaborating also internally here. And we were happy to find out that our new brothers and sisters in the company are already collaborating with Canadian players. So that's a good start, probably. Thanks for your interest, and ask your questions now, please.
Thank you, Alexander. Are there any questions coming from the embassy audience?
When you're talking about cooperation on radar services, is this only limited to services, or do you know about scenarios where, like spacecraft manufacturers, MDA and Astrium, are considering to cooperate on the construction of radar satellites, which are actually filling niches in the market?
Okay, so on the parts procurement side of satellites, both companies support each other, both in SATCOM and Earth observation, but that's the nitty-gritty pieces that you need on a satellite. On the radar business, that's a bit more difficult because one team is following a radar C-band strategy, the other one is looking into very high-resolution X-band. We have been looking into that with some detail, but we have not really found a big common ground on the technology side. So today we believe it's more on the ground segment, where you need similar data streams and philosophies, and you can resource synergies, and it's on the service use of the data. Correct me if I'm wrong, John, please. Comment. That was thumbs up. It means sort of yes, I believe.
Okay, are there any questions on the Gatineau side?
Yes, actually it's a comment and a question. I would like to comment and take this basically from space back down to Earth. One of the collaboration areas that we do have, and Thomas Weissenberg mentioned this already with our ground station up in Lübeck, for instance, that is on the ground station development because, once these data are downlinked, well, first of all, they need to be downlinked. They need to be downlinked in a near real-time fashion to really cater to clients like Canadian Ice Service, Fifth Ocean. D&D. So that's an area of collaboration that we have already developed quite well between Germany and Canada. Then in addition, it also means that all these data have to be handled, which means we have to have a very fast reacting archive and access system. And I think that is another area where we need to reinforce or need to expand our collaboration. That's where we can also learn from our Canadian colleagues. As German agencies and German industries. But then on the other hand, when it comes to actually applying these data, then that's the question for Alex. Alex, what do you expect us to get out of a collaboration when you're talking about application development? Because it also means that we need to develop new software. There's a lot of talk about, yes, we've done a lot of research, a lot of science has flown into it. So basically we're done, let's move on to other fields. At the same time, we all know that a lot of customers don't want to see a black and white radar image because they don't have the expertise to exploit it. So what exactly do we expect out of this collaboration in order to make these images actually work?
Okay, I agree with you, Wolfhard. It's not about the static image, it's about extracting information quickly. And that needs an integrated data flow for both data sources. It needs an operational software tool that can extract information like ships or the AIS signal in a near real-time fashion and transmit it into a situational awareness center. Such a software does not exist. DLR has developed some parts of software that is good for radar, for TerraSAR. MDA has developed, together with DRDC and other Canadian players, software that is good for RadarSat, but we don't have anything that is integrated. So that is necessary. There's a major gap to be closed here. Also, if we think about integrated use in terms of interferometry, it's very dedicated systems and software today. There's nothing integrated yet that you could make operational use of. And that's actually, when it comes to service development, after the concept is there, that's the costly part, to have the operational workflow established.
Thank you.
But I think there's colleagues from Verum that know that type of the business much better than I could. If you like to comment, please.
Sören Schwarzer, Verum Software and Systems. Thank you for handing over the microphone to me. Well, we would be interested to contribute with software solutions, as we have experience with multi-mission payload data ground segments, long collaboration with DLR and others, and Infoterra as well. So if there are new challenges in this area, we would like to contribute there.
Mm-hmm. And I think that shows very well also the value chain. There's the research teams at DLR, at CCMAO, at CSA, and other players like DRDC. They do clever algorithms. There are some industrial players very often that do some little tools here and there. But then when you try to use it operationally, you need to integrate it into a workflow that is optimized and engineered. And that's the business of another part of the industry, like Verum. So only if you put all these players together, you will get a good system.
Good, we should perhaps finish there. Alexander, thank you very much.